Hello students, let's see the next part of this chapter, which is IUPAC nomenclature. So in IUPAC nomenclature, suppose this is a compound CH3, CH3. If we have certain rules that how to name this compound, so we can following the rules, we can name millions of compounds, right? Similarly, for example, CH3COH is popularly known as acetic acid. However, it is not its IUPAC name. Its IUPAC name is ethanoic acid. So all the compounds which have COOH ends with oic acid. This is again a rule. So let's understand these rules. So first of all, I'll be discussing the case of hydrocarbons. Hydrocarbons are the compounds which have carbon and hydrogen only. So here the first rule says that longest carbon chain is to be selected. Here we have 4 carbons in the longest chain. And in the second case, if I choose this, so I have 4 carbon, whereas in this I have 5 carbon. So 5 is the longest chain. So the first compound has 4 carbons in the main chain and second has 5 carbon in the main chain. So if number of carbon atoms are 1, 2, 3, 4, 5 and so on, so they will be named as a meth, het, prop and so on. So you can just pause this video and you can memorize the number of carbon atom, and this is known as root word. So these both the compounds are alkane because they contain saturated bond. Saturated means no double or triple bond. So first compound will be named as 2-methyl because methyl is not included in the main chain, 2-methyl-butane, and second one is 3-methyl pentane because it has 5 carbon and no double or triple bond, so ane will come at the end. So generally the IUPAC name of an organic compound consists of prefix, root word and suffix. For example, cyclohexane. So cyclo is prefix and hex is the root word, and ane is again showing that there is no double or triple bond. So it is a saturated molecule. Alkyl group which cannot be included in the main chains are treated as branches. For example, here this is a branch, 2-methyl is a branch. Lowest set of locant, very important rule. Numbering of locant or branches is done from the side where it gets the lower number. For example, here the longest carbon chain has 7 carbon, but if I start numbering from left, I get methyl at 3 and again a methyl at 6, whereas from right hand side I get at 2, 3 and 5, right? I think from left to right it is 3, 5, 6. I didn't say 5 earlier. So it is 3, 5, 6 from left to right, and right to left it is 2, 3, 5. So 2 is the lower number than 3. So that is why we'll start numbering from right to left. So I have written many examples where lowest set of locant is to be used. So you can just pause the video and look all the examples and practice yourself. So this one is 2466 tetramethyl-octane. This one is 4,5-diethyl. 2,6-dimethyl-octane. We'll write ethyl before methyl because ethyl starts with E. So first of all, we have to look at the lowest set of locant, and then second we have to look at the alphabetical order also. However, we will always write all the prefixes in the alphabetical order. So here also you can see that if you start from numbering from left to right, then what will be the lowest set of locant. So in case of locant alphabetical order, as I have already told you, so in this molecule if you have a look, so we are getting methyl at 4 and ethyl at 5. From left to right we are getting ethyl at 4 and methyl at 5. So since ethyl starts from E, so ethyl should get the lower number. So right to left is the preferred way, so that ethyl can get the lower locant. Alright, so first lowest set of locant and second is the alphabetical order. You can again pause the video and practice all these examples which I have written. I have written their answers also. These cyclic are not important for CBSE as of now, but if you want, if you are preparing for JEE and NEET, you can practice them as well. Let's see this double and triple bond cases. double bond and triple bond. Again, the lowest set of locant is to be followed. So double bond here is coming at number 1. When it is coming between 1 and 2, we considering lowest set of locant, we'll write only 1. And ine triple bond is 5 and 6, so we'll write 5. So oct 1 ene is for double and ine is for triple bond. Next one is oct 5 ene and 1 ine. So double and triple bond do not have any priority. Their priority is decided by lowest set of locant followed by the alphabetical order. Homologous series, you have already studied it in class 10th, that what is a homologous series. A series in which all the molecules can be represented by same general formula, they can be prepared by same methods of preparation, they show same chemical properties, they show a regular gradation in physical properties, means their boiling point and melting point increases as we move downward regularly. So first homologous series is carboxylic acid. Please mind it that I have written all the functional group in the priority order. Carboxylic acid is written at number 1 because it has the highest priority. So its general name is alkanoic acid. So members are methanoic, ethanoic and propanoic acid respectively. Their common names are formic, acetic and propionic acid. So again, general IUPAC name is alkanoic acid. If number of carbon is 1, you'll write methanoic, 2 ethanoic, like this. So here in this particular case, it is a hexanoic acid in which there are 2 branches of methyl at carbon number 3 and 4. So the name is 3,4 dimethyl hexanoic acid. Similarly, this here you can see that I have used the suffix carboxylic acid. This suffix is used when carbon of carboxylic acid cannot be included in the main chain. So that is why the name is cyclopentane carboxylic acid. So you can understand that this molecule will have a total of 6 carbon. In this compound, all 3 COH group are connected to the main chain. So they should be treated equally, and hence the name propane 1, 2, 3 tricarboxylic acid. So propane and then 3 carboxylic. So total 6. In this case, 2 COH are a part of main chain, but this COH is not connected to the main chain. So hence it has to be written as prefix. And so it is written as 3-carboxymethyl-pentane 1,5-dioic acid. Then we have sulfonic acid. Sulfonic acid has a general formula CnH2n plus 1 SO3H. It is name is alkyl sulfonic acid. If number of carbon is 1, you'll write methyl, 2 ethyl and 3 propyl, like this. Its prefix is sulfo. So here we can see its naming. Next is ester, very important. Its name is alkyl alkanoid. The part which is connected to oxygen is written as alkyl and the remaining is written as alkanoid. So if you start with hydrogen, the first compound you get is an acid, not a ester. Similarly, the second one, if you write it this way, it is acetic acid. But if you attach CH3 with oxygen, then it becomes an ester and name is methyl methanoid. Next one is acid chloride. General formula RCOCl. General IUPAC name is alkanoyl chloride. So methanoyl, ethanoyl, propanoyl, etc. So these 4 are actually called acid derivatives. Ester, acid chloride, acid amide or acid anhydride, because they have been derived from acid. They can be obtained from acid by the reaction of alcohol, HCl, ammonia and heat respectively. So acid amide is the next one. RCONH2 is the formula. General IUPAC name is alkanamide. Again, you replace R with hydrogen CH3 and you will get the corresponding name. The next one is alkyl cyanide. Here its IUPAC name is alkane nitrile. Again, you have to calculate the total number of carbon and the name is alkane nitrile. When it is written as prefix, it is cyano. So 4-methyl hexane nitrile. Next, aldehyde, it is written as alkenyl. CHO is the functional group. First compound is methanol and then ethanol, propanol, etc. I have written few cases. You can pause the video and check and just consider them. In this case, we have COH as principal functional group, so it is an oic acid. Aldehyde will be written in prefix, and we have one more prefix, which is ethyl. So you can check the name. Next is ketone, RCOR dash. Both the R can be same. If they are same, we'll call them symmetrical ketone. If they are not, we'll call them unsymmetrical ketone. General IUPAC name is alkanone. So we have propanone, butanone, but when we have pentane, so there can be two cases, pentane 2-one and pentane 3-one. Similarly, in hexane also we can have two cases. So in this particular case, you see that we have one carboxylic acid, one aldehyde, and one ketone, and one ethyl. So basically one suffix, so it is an alkanoic acid with ketone, aldehyde, and ethyl as prefixes. So again, they'll be written in alphabetical order. So aldo first of all, then ethyl, and then oxo. Oxo is the prefix for ketone. Then we have alcohol. Its name is alkanol. So methanol, ethanol, propanol, etc. In this particular molecule, we have 3-ethyl, 5-methyl hexanol. So again, ethyl starts with E, will come first. Then we have aldehyde, and then hydroxy group. So this is 3-ethyl 4-hydroxy pentanol is the name. Last, in NCRT 10 functional groups are given only, so that is why the last one is amine. So alkanamine is the name, methanamine, ethanamine, propanamine, butanamine. This one you can skip as of now. Alkene, double bond, ethene, propane, butene. Again, in case of butene, there will be two cases, 1-ene, 2-ene, and one more chain isomer will be formed. In alkyl, ethyne, propyne, butane, two cases again. In pentyne, there will be three cases, two position isomer, one chain isomer. Then I have solved all the questions which are given in NCRT in text exercise. You can just pause the video and just check this. Then we have a nomenclature of some aromatic compounds. Mainly aromatic compounds given here are the benzenoid aromatic compound, means which have benzene ring. When you are making a benzene ring, you should make a circle instead of the solid line, because solid line do not represent resonance. So monosubstituted benzene means one of the hydrogen has been replaced by a group. If it is CH3, we call it toluene. If it is OMe, means OCH3, it is methylbenzene or anisole, methoxybenzene or anisole. In case of disubstituted, two hydrogens are replaced. So in case of di, we can get ortho, meta, and para. Then we have these cases which are tri-substituted. Tri-substituted means benzene with three substituted group. So first one is chlorine and nitro, and then these are the cases which are given. This is phenol. When benzene gets one OH, it is known as phenol. This is aniline, and then when aniline is there, so the carbon to which NH2 is attached is always named as 1. Similarly, in anisole, the carbon to which OMe means methoxy is attached, it is 1. All right, thank you.